Hello everybody, and welcome to the ROS in a Single Week course. In this first chapter, you are going to see a small preview of some of the main concepts you are going to learn along this course. But before starting with this first chapter, let's introduce you to the Robot Ignite Academy layout. As you can see, in the left side of the screen, you have the notebook section. In the notebook section, you are going to be presented with the different notebooks of each of the chapters of this course. You have to follow these notebooks in order to complete the chapters and finally complete the whole course. These notebooks will contain some theory and lots of exercises so you can practice every new concept you learn. In the center of the screen, in the top section, you have the IDE. The IDE will allow you to work and interact with all the files that you will create along the course, which, let me say, they are a lot, in a graphical way. You can create new files, new folder, delete files, open files, edit them, whatever you want. So in the IDE section, you will be able to work with all your files in a graphical environment. Here in the center part of the screen, but in the bottom side, you have the shells. These are normal Ubuntu shells that will allow you to interact with ROS, launch programs, and whatever you have to do. In this case, you have 4 different shells, which you can switch between them, because when working with ROS, you usually need more than one shell, right? Finally, here in the top right corner of the screen, you have the simulation window. In this simulation screen, you will be presented with different simulations depending on the chapter you are that will help you in the process of learning ROS. In this case, we have the lovely Kabuki Robot, which will help us in this first chapter. Great, so let's start. As I told you before, in this first chapter, we are going to see a preview of the main concepts that you will learn during the course. But remember this is just a preview chapter. You won't really learn any important concept here. This is just to let you preview how the course and what are the different concepts that you will learn along this course. So probably one of the questions that led you here was, what do I need in order to learn to program a robot with ROS? Great. Let's see. The first thing you need is to learn some basic concepts. As always you start to learn something new, you first need to learn some basic concepts that will help you later in order to build more complex concepts, right? For instance, you can't learn to run before you know how to walk. That's why this course starts with the basic concepts chapter that will teach you some basic concepts of ROS that you need to know in order to be able to understand more complex concepts. So the first thing you need are basic concepts. Great. And what's the second thing you need? Well, the second thing you need to learn are ROS Topics. ROS Topics are probably the main and most important concept in ROS. ROS manages almost all its communication through topics, which means that with topics you will be able to communicate with your robot. For instance, to make it move, or to read sensor data. So remember, ROS topics are the most important concept in ROS, so you will need to learn them very, very well. Now I want you to do this example 1.1 so you can start to interact with ROS topics. Let's now execute this command here. For that, we'll go to one of the shells and we will type this command, which is ROS topic pub. One thing I want you to know is that when working with ROS, you will need to autocomplete a lot. This will save you lots of time, and it's also useful to know if you are using the right command, or if you are writing it in the correct way. For instance, if I write ROS top, ROS to, and I press the tab button, it will autocomplete me to topic. Then I can write pub, then I will write /cmd_vel, which, let me say you, is the name of the topic. And then we are going to write here twist. And finally, we will do a double tap that will autocomplete this command. Yeah? Now, before executing, let me explain you a little bit what this command is. This command is used in order to publish, as you can see here in the pub keyword. This command is used to publish into a topic. In this case, we are publishing into the topic cmd_vel, which is a very known topic in ROS. And what we are publishing? We are publishing a twist message, which structure is the following. Yeah? Basically, the command vel topic is used in order to send commands to the wheels of the robot. So it is used in order to move the robot. Yes? And we can apply different velocities. For instance, you have the linear velocity. We have also the angular velocity, which will make the robot turn. And in this case, we will apply a 0.5 velocity to the linear x, which will make the robot move straight forward. And we will also apply at the angular z, which will make the robot turn. We'll put here also a 0.5, which is these magnitudes are in meters per second. Great. So, what do you think it should happen if I execute this command? It will start writing into the command vel topic, and it will publish a 0.5 linear x velocity, which will make the robot move forward, and also a 0.5 angular velocity, which will make the robot turn. So probably it will make the robot perform a kind of circular move, right? Let's try it. There you are. As you can see, the robot begins performing a circular movement. Great. So this has been done by publishing into a topic. That's why topics are that important. In order to stop this command, you can use Ctrl+C. But as you will see, the robot will keep moving. This is because the last message we've published, will be the one that the topic keeps reading on and on. So if we want to stop the robot, we'll have to publish again a message, but in this case putting the velocities to 0. So let's do this. Great. Let's wait so we can stop it right in the center where it was. More or less, yeah. So there it is. It will stop it. Great. So summarizing what we have done, we have published into the command vel topic, which is in charge of moving the robot, let's say, and by publishing into this topic, the robot started moving. So the one thing I want you to learn from this first example is that topics will allow you to communicate with your robot, either for sending commands to your robot, or also for reading information from your robot, from the sensor, for instance. Yeah? So topics will allow you to communicate with ROS, which means that will allow you to communicate with your robot. That's why topics are so important. Great. I'm sure that at this point you will have lots of doubts lots of questions, but remember, this is just a preview chapter. You will learn deeply how to work with topics, and what topics are, and what you can do with topics in chapters 3 and 4 of this course, which are dedicated to topics. Great. But is this the only way you can communicate with ROS? You can communicate with robots by using topic, by publishing into a topic? Not exactly. Let's move on. So the third thing you need to know about ROS, you need to learn, is about ROS Services. A ROS service is, as the word itself says, it's a service that your robot provides. So with ROS Services, you can code any kind of functionality for your robot and then provide it so anyone can call it. Yes? ROS services are a little bit more complex than topics in the sense that they have two parts. In one side, we have the server, which is the one that provides this service, and in the other side, we have the client, which is the one that calls this service. For instance, you could create a service that moves the robot for, let's say, 4 seconds, and then it stops. Then anyone will be able to call this service to make the robot move for 4 seconds and stop. Well, let's try an example as well. Example 1.2. So you can also interact with our service, yeah? And you can start to see more or less how it works. So first of all, I want you to execute this command here. Let's do it. ROS launch service demo service_launch.launch. Great. And then after this, I want you to execute this other command. You can do it in another shell. So let's do the ROS Service. Always remember to tabulate in order to autocomplete the messages. Yes? Don't forget this. This is very important, very useful in ROS. Okay, let's see. ROS Service call. We'll add here the service demo, and then we will do a double tap in order to autocomplete the message. Yeah? Great. Let's execute this for now, and then we will explain what all this means, or more or less what this means. Okay, so let's execute it. Great. So I can see the robot starts moving, performing a circle, and it stops at 4 seconds. Great. So this service is in order to move the robot performing a circular movement for 4 seconds, and then it stops. Great. So what we have just done, with this first command, we have started the service. We have made this service available for anyone to call it. So that's what we have done here in this first command. We have started the service, just that. Then here, in the second command we have performed, we have called this service. Yeah, as you can see, using the ROS service call, we have called this service, which name is service_demo. This is the name of the service. And finally, here we are providing a message, a call message, an argument to this service, which in this case it's empty, let me say. And then by calling to this service, the robot has started moving for 4 seconds, and then it has stopped. In this case, this service provides movement, but you can code a service for anything. So services are also a very powerful ROS tool. Again, let me say, I'm sure you will have lots of questions. There are lots of things that I am not explaining, but this is not the place to explain them. We will explain it with lots of details during the course, during the different chapters. This is just a preview of the course. So for instance, in the case of services, you will learn how to work with ROS services in chapters 5 and 6 of this course. So don't worry if you don't understand much at this point, because while you go along the course, you will be able to understand this perfectly. You will be able to write your own services and do whatever you want. Great. So let's summarize until this point. We have seen that first, you need to learn some basic concepts, as always. Second, you need to learn about ROS Topics, which is a very, very, very important part of ROS. Third, you need to learn about ROS Services, which is what we have just seen. But do you think that's all? With services, topics, and some basic concepts, you know everything you need to know about ROS? Obviously, the answer is no. So let's go on. In fourth place, you will need to learn about ROS Actions. ROS Actions are quite similar to ROS Services in the sense that they also allow you to provide a functionality of your robot so anyone can call it. But ROS Actions add a little bit more of complexity. As I said, they are similar to ROS Services, but there are some important differences. The most important one is that with ROS Services, when you call a service, you have to wait until your robot performs whatever that service does. For instance, in the case we've seen previously, the service was in order to move the robot. So when I call that service, I have to wait until the robot performs the movement and stops, and the service stops, in order to be able to continue doing things with the robot. So while the robot is doing this service, I cannot do anything with it. In actions, this is different, because while your robot is performing the action, whatever that action does, you can still do other things, other stuff, while the robot is performing, while the robot is executing that action. Did you get this difference? This is the most important difference between services and actions. There are also more differences. For instance, in actions you can use feedback. You can get feedback of how the action is going while it is being executed. But well, don't worry for now. You will learn all that in the action chapters. So for now we are just having a preview. So let's do this example 1.3 so we can work a little bit, we can interact with an action. So first of all, let's execute this ROS launch command as we did before. We will kill the service, we launched it before, and we'll then launch this action demo action_launch.launch. Great. We execute this command, done, and then we will again execute this second command here. So let's go to another shell, type this ROS topic pub, it is /action_demo/goal, and then let me see, it's action leap test action. I am auto-completing. Remember to autocomplete, and then double tap, and the structure of the message will appear. Great. Now here, at the end of the message, you can see here a goal. Yeah. Now here I will write 4. I want you to write 4 now also. I will explain you later what this is. Yeah. But for now, write 4, and let's execute this command as well. So let's go. Okay. I see the robot keeps moving. It is doing something similar than in the service. Yeah, it also moved. It looks like for 4 seconds or something like that. Okay, let's for instance try now to repeat this command, but now put, I don't know, 8. Let's see what happens. Great, so the robot moves as well. Now it looks like it's moving more. Okay, so let me explain it now. So this number you are introducing here is the number of seconds that the robot will be moving. So this is how this action is coded. It works like this. Yes? You can provide the number of seconds you want the robot to keep moving until it stops. Okay, but what we have done here, as you can see, this first command we have launched here is very similar to the one we did in services. And yes, it does the same. So with this command, we are starting the action. We are launching the action. We are making it available so anyone can call it. Great. And in this second command here, we are kind of calling the action. But as you can see, the command we are using is almost the same that the one we used in topics. It is also a ROS topic pub. It changes here and here, but it is also a ROS topic pub, which I told you before that this command is used in order to publish into a topic. And that's right, because actions at the end work with topics. And in order to call an action, you have to publish into the goal topic of that action, which is the thing we are doing here. The action name is action demo, and the goal topic of this action will allow me to publish into this topic in order to start the action. So this is basically what we are doing. We first launched the action to make it available, and then we called this action by publishing into its goal topic. Yes, I know, it's a lot of information, right? Don't worry, you don't have to learn this now. This is just to let you interact and to let you see, to let you have a glimpse of what you are going to do through this course, of what you are going to learn through this course. Yes, you are going to learn, obviously, all the stuff you need to learn about actions in the action chapters, which are, let me see, chapters 7 and 8. So in chapters 7 and 8, you will learn all you need to know about actions. Yeah. So for now, don't worry. I know it's a lot of information. I am not explaining much of anything because, as I said, this is just a preview unit. Great. So let's see the last main concept you need to learn in order to work with ROS, in order to be able to program a robot with ROS. The final concept you need to learn about are the debugging tools. So if you never worked with robots, if you never worked with simulations, if you never worked with ROS, let me tell you this one thing. You will have to deal with errors. That's for sure. But fortunately, ROS provides a huge set of debugging tools that will allow you to find these errors and to debug them and to be able to easily find them and correct them. But there's one tool which is the most powerful tool and the most important tool of all of them, which is RViz. RViz is an extremely powerful tool that ROS provides, and that will help you for sure in order to find errors, to find bugs that your codes or that you experience with your robots. So in this example 1.4, I want you to have a first look at RViz, a very, very simple look. So let's go. First of all, I want you to execute this command here. Let's do it right here. Great. So I'm going to clean a little bit this, and I'm going to execute this ROS run RViz. Great. So here it is. This has started RViz, but as you can see, nothing appears, nothing has changed yet. So you may be asking, okay, so what is this? Don't worry. Next step is to click in this screen icon here. You can see it here in the IDE section. So here you will be able to open a new tab, which we call the graphic tool, that will allow you to work with all the debugging tools that ROS provides. So always you click in this button, you will open a new tab, and then you will be able to visualize, for instance, RViz or all the other debugging tools that ROS provides, like RQT or whatever. You will see them in the course. So let's go again to this RViz window. Great. So as you can see, here opens RViz. But let me go back 1 second. Before going to RViz, let me say I will be following the example 1.4. So in case you ask, well, what are you doing? Okay, I will follow this example 1.4. Yeah, all these steps. I have launched this ROS Run RViz service now, and now I will be following these steps, A, B, and so on. So let's go to RViz, and let's see what we can do here. Okay, the first thing I want you to do is to change this fixed frame. Yeah, we'll come here, we'll open here, and we will select the base link frame. Great. Perfect. Now I want you to go here to the Add button. Let's click it, and we will see different elements. In this case, let's select the robot model. Yeah? Let's select this robot model. We click, and as you can see, there's appeared something here. Yes, this is the Kabuki Robot. So this is the robot you see in your simulation, and now it has appeared here in RViz. Great. So now by adding this robot model, we can visualize also the robot here in RViz. Perfect. Now I want you to add a second element. Let's open again this Add screen, and now we will select the laser scan element. Great. So apparently nothing has appeared now. Okay. Let's see what we can do. First, let's open this laser scan in order to see its configuration. And here we can see a topic section, and we will click here, and we will select this Kabuki/laser/scan, which, as you can guess, is the name of a topic. So let's click here. We'll press enter, and suddenly it appears something here. A red line has appeared here. Strange. Can you guess what this is? Try to think. What can this red line be? You can have a look at the simulation. Have a look at how the simulation is. Yeah? Have you guessed it right? Do you have an answer? Not yet? Okay. What this red line represents are the readings of the laser of the Kabuki Robot. Yes. So here, the topic I have selected here, which is Kabuki/laser/scan, it provides me the readings of the laser sensor of the Kabuki Robot. So by using RViz, I can visualize these readings and turn them into this red line you see here, which actually represents the wall we have in the simulation. So these laser beams are hitting the wall and are detecting that there's something in front of the Kabuki Robot, which, as you can see in the simulation, this something is this wall. Yeah? What do you think? Amazing, right? Well, but this is very little part of what RViz can really do. You will be able to learn and to see a lot more of RViz in Chapter 9. And not just RViz, but also lots of other debugging tools that ROS provides and that are very interesting and that will help you in order to find your errors and to solve them. And let me say if you work with robots, if you work with simulations, you will have to deal with errors. Great, and this is all for this first chapter, this course preview. So, summarizing, what you need to learn in order to be able to program a robot with ROS, and what you will learn by completing this ROS in a single week course are first, basic concepts, next, the ROS topics, third, you will learn about ROS Services, fourth, you will learn about ROS Actions, and finally, you will learn about the ROS Debugging Tools. So that's it. I hope you enjoyed this course preview. I hope you are thrilled and you cannot wait to start learning ROS. So what do you say? Do you want to become a ROS master? Do you want to be able to program any robot with ROS? Don't doubt it one more second. ROS in a single week is your solution. ROS in a single week is the choice. So don't waste your time and start learning ROS. Goodbye and see you soon.